Video number 119, graphing ellipses. We're asked to graph the ellipse, find the coordinates of the foci, domain, and range. Let's take a look. It says, first of all, and it would be nice if I knew how to type. First of all, let's look at a circle. Then we'll compare it to an ellipse. Definition of a circle is a set of points that are equidistant to a center focal point. These points here are all equidistant to that one. Okay, that would, if I drew this perfectly, that's what each one of these points is. It's equidistant to that one. That's why all the radii are congruent, because that's just the definition of a circle. Now, definition of ellipse, a set of points whose sum's distance is constant. Sum's distance from two fixed points. Here's the two fixed points. Well, if you take this point right here and you were to add these two distances together, let's just make up some numbers. Maybe this is 13, maybe that's 7. If you add that together, the total is 20. Okay? Well, if you were to go over here, let's say, the 13 got longer, the 7 got longer. This point would not be in this particular set of points, right? But if you went a little bit further to the left, the 13 would get smaller here, maybe go down to a 12, and then maybe the 7 would get longer and go up to an 8. Okay, so what ends up happening is you end up with this kind of a relationship. All of these points would add up to a total of 20 in this particular case. This is what an ellipse is. Okay, now this is the standard form for an ellipse. It's x squared over a squared plus y squared over b squared equals 1. It should look familiar. It should look a little bit like a circle, and a circle is just simply x squared plus y squared equals r squared. And of course you could, should be equals, you could divide by r squared if you wanted to and do x squared over r squared plus y squared over r squared equals 1. And you could rewrite the equation of a circle to look a little bit like this instead. Well, in this case, what makes an object elliptical rather than circular is that one of these, x or y, is a little bit wider. See, in here the x's are kind of wider than the y's, right? See how that would work? And of course, if it was this shape, we would say the y's are larger than the x's. That's pretty much the general idea of an ellipse. So what we're going to do is, we're going to count on this being our standard form, and you'll see how easy this really is. The first step is we want to make the 36 a 1. So we divide everything by 36. You get x squared over 9, y squared over 4. Right here, 36 divided by 36 is 1. Here's your standard form. Now, okay, 9 is in the a squared position. 4 is in the b squared position. This means that a is 3, b is 2. This is an easy graph, okay? So what you'll have here is this. I'll just go ahead and put it right here. The center is 0, 0. Same overall theme. Nothing's being added or subtracted to x and y. That's why we're starting the origin for the center. A is 3, B is 4. Guess what? Go to the right 3, left 3, up 2, down 2. Guess what? That's the ellipse. Now, I guess you can put the little tick marks in here if you want to make it look perfect. Alright? Alright. Now, the horizontal axis is the major axis. So this is the horizontal axis. Okay. Now, it says to find the foci, we'll need to find the c value. Circular objects always have a Pythagorean relationship. Alright? That's the other beautiful thing about circular objects. A circle, if I draw a perfect circle here, okay, take any 2 points, excuse me, any triangle here. You could draw a right triangle here, okay, and this could be x, this could be y. Guess what? All right, Excuse me, this is R, R, and that's C. Okay? But it's not just limited to this. You could do this. Here we go. Here's a better way to do it. Let's put a center. Let's put a circle at the center. Alright? Let's call this the point A, B. Alright? Or actually, let's call it XY. Watch this. This is beautiful. Let's call it XY. And then draw a right triangle right here. Does everybody agree? That's got to be X. Therefore, that has to be Y. Well, what's this? R. X squared plus Y squared equals R squared. Pythagorean theorem. Every circle has a Pythagorean relationship. Now, your Pythagorean relationship here is going to be a little bit different. You see, A is actually going to be larger than C. Okay, here's the deal. This distance here, here's foci number 1, foci number 2. This is the center. Guys, the C value is going to be the distance from the center to the foci, or one of the foci. Now, that means this is C. Well, look at this, guys. What's larger? A, or C? Definitely A. Therefore, your Pythagorean relationship is actually this. A squared is the one that's by itself, equaling C squared plus B squared, which means that C squared equals A squared minus B squared. Now, beautiful thing about this formula, those numbers are already worked out. A squared is 9, B squared is 4. C squared equals to 5. C equals root 5. Therefore, this would be root 5, and then you would be over here at negative root 5. Domain and range of this bad boy, -3 to +3. Range is -2 to +2. And it's a beautiful world. Let's take a look at the next one. This time, what do you have? The center has been translated. The center has been translated. The center is now 1, -3 by the same theme we've been using through all the videos. And anytime you got a minus, you do the opposite. You got a plus, you do the opposite when you're inside parentheses. Definitely A is 3, definitely B is 5. You can see it right there, square root of 9, square root of 25. The major axis is the vertical. Why? Because the 25 is larger than the 9, and the 25 is where? Under the Y. Unlike this one, the 9 was under the X, therefore the major axis was the plus or minus 3 on the X's. C is 4. Okay, let's go ahead and put the foci at 1, 1, and 1, -7. Let's actually verify this first. 1, -3, 1, 2, and -3. Okay. Let's see here. What do you got? A is 3, B is 5. So you can go to the right 3, 1, 2, 3. That's a 4. To left 3, 1, 2, 3. Right here. Up 5. 1, 2. Oop, 1, 2, 3, 4, 5. There you go. Down 5. 1, 2, 3, 4, 5. Down here. So our ellipse is taller this time. Of course, I didn't draw this really all that well. But anyway, it's progress, not perfection. You're in good shape. Now, the foci, guess where they are? Not this way. They're going to be along the major axis. So you're going to have to go up this way 4 and that way 4. Takes you at 1, 1 and 1, -7. Okay? Domain, -2 to 4. Range, -8 to 2. Any questions or concerns? Good times. Talk to you later.